So now that we're all hopefully JavaScript experts, you guys hopefully understand, all of JavaScript perfectly well. So we're ready to move on to some advanced stuff. We're going to talk about React. So yeah, I'm mostly kidding. It's okay if you're still kind of figuring out JavaScript. Hopefully this will still kind of make sense and maybe even help you understand a little bit better as we go. So what is React? React is an open source JavaScript framework, and it was built by Facebook back in 2013. So it's been around for a good little while now. And it's used for building user interfaces on the web. So, a few things to point out there. One, it's open source. So Facebook built this for them to use internally. They used it, in the actual Facebook code. But then they chose to open source it so that anyone else could use it. So they said, hey, this is useful. We want to go ahead and make this publicly available. And it's also open source now to where other people can contribute to it. For instance, we pull up the React source code on GitHub. You can, one, look at the source code, which is cool. So you can, dig down into the source code if you want to see how React works. And then you can also contribute to it. So, if we look at these pull requests, if we look at the closed ones, see ones that have been accepted, a lot of these likely are submitted by non-Facebook employees. Sometimes you can tell. No, that's a React core team person. But some of these are going to be people that aren't Facebook employees. They're just people that, maybe work for other companies that use React. This guy also is on staff, but anyone can contribute to it. So if there's an issue that you see, anyone can contribute, submit a pull request. So that's the whole idea of open source software. So really nice. So React focuses only on the view layer. So a lot of the kind of popular JavaScript frameworks, things like things like Angular or Ember.js, these are kind of full-featured frameworks that really handle all aspects of our application. So they handle the model in that they'll let you set up your data structures and set up your data storage and handle all of that through a model interface. They'll handle your view, but then also the controller that kind of ties the view to the models and renders your models and things like that. React doesn't have any idea what your data is. It doesn't tell you how to structure your data at all. It also doesn't, connect your data to your models, to your views. It only handles the view. So it only handles the presentation layer. It only handles your interface, your actual HTML, essentially. It does so in a really neat way, and it makes it really easy to connect your data. So, we'll talk about that. It's not very hard to, add our data to React, but it really only focuses on the view layer. So there's other libraries in the React ecosystem that kind of help us build more complex applications. So React Router, for instance, if you're building an application that has different URLs, you can use React Router as a controller to handle different URLs. So if you want, for instance, we're rebuilding our Zimride application in React right now, and we're using React Router. So zimride.com/rides is all handled via React or /rides/1234 to view a specific ride. React Router takes that URL and breaks it into its components and says, okay, I need to, render a certain component because it's a rides page, and I need to, here's the ID of my ride. So it handles that URL stuff for you, which is really nice. All happens in JavaScript. You can build a full-featured application with multiple URLs that doesn't hit, it doesn't go to a new page each time you go. You can click a link that goes to /rides, and it just is handled via JavaScript, and it updates the view for that new URL without having to go to a different page. So super nice. But that's React Router. So it's an additional library on top of React that you pull in. Redux is really popular. We use Redux as well. It does global state management. So again, React you can handle your data using state that we'll talk about, and each component has its own state that we can add our data to. Redux kind of gives you a global state management. It makes it a lot easier to handle lots of data. We won't really deal with Redux in class, but if you're building a larger application with multiple components that all need to kind of interact with the same data, Redux is really, really nice for that. It adds some complexity as well, though. React Native is a framework that will compile a React JavaScript app into native iOS or Android application code. So that's super nice. It's one of the things that's made React so popular is by using React Native, you can write your application once in JavaScript and then compile it into Swift or Java for Android. So that's really nice. Facebook uses this for all of their mobile apps. They use React Native, and they're actually reusing the same components from their website to their iOS app to their Android app. So you only have to write your components once, and you can compile them into these different places. So super nice. We use React Native at Enterprise. I don't, because I'm not on a mobile team, but our mobile teams do, because it's a lot easier to bring in developers that know React, and they can write an application once, and it can become an iOS application and an Android application, and it compiles to both. So really, really nice. So React Native is honestly a big reason a lot of people are using React. There's some other ways to do similar things. There's like, Apache Cordova and even doing kind of like iOS apps that really just pull in a web page, stuff like that. But React Native actually compiles to native code. So it creates a native app for you from your JavaScript. So super nice. So getting started with React. So you can just load React via CDN, just, with a script tag, and use it in a really basic form without any of the fancy features that we'll talk about today in class. So without ES6 or JSX, or any sort of build step. So you guys have been dealing with the NPM deploy and all this kind of stuff. You can do React without any of that. But without ES6, React is a lot more verbose. It's a lot more difficult to use. I'll show some examples of what it looks like without ES6 here in a second. So it's really recommended to go through the hassle of setting up the build process. Really, you want to use ES6 when you're using React because it really makes things a lot nicer. And we'll talk about ES6 a little bit more here in a second. Facebook created a command line tool called Create React App that does much of the setup for you. So that's what I used for your starter code for the application. So really, I only spent about 10 minutes on it. I ran Create React App and I gave it a name. And I went through and changed one or two things on it. But really, it does all the setup of all the tooling, and then you can just run that npm start and npm deploy, and it knows what to do because of Create React App, that tool. So if you want to look at that tool, so if you want to just start from scratch with the React app sometime, even just to play around with or for a project, if you go to this link, that has all the documentation for Create React App, how to use it. If you want to like add Sass compiling to it, there's a note in the documentation on how to do that. If you want to add React Router, there is explanation of how to do that. It has really good documentation on how to use it. So there's several tools that we use to compile the React app. So again, React, we're using ES6, which is the new version of JavaScript that's not fully supported by browsers yet. So we have to compile it into normal JavaScript. And there's a couple of tools that we use. The first is Babel. So Babel is a tool to transpile our ES6 into plain JavaScript. And again, Create React App sets all this up for us, so we don't have to worry about setting up Babel. It does it for us, but that's what it's using behind the scenes to convert our ES6 React into plain JavaScript that the browsers can read. Webpack is a really popular tool now as well. Webpack is just our packager. So it takes all of our JavaScript, all of our React app stuff, and it packages it all up. So Webpack is actually what runs Babel. So Webpack says, okay, here's some ES6 files. I need to run Babel on those files. And then it will combine all the results of those into one JavaScript file for you. It will minimize or minify the file, remove all the white space and make it all one line. So it's really small. Things like that. I'll also compile all of our CSS and pull it all into one file because we've broken out our CSS into multiple files. So Webpack will look through all of our JavaScript and say, okay, here's the CSS file, here's the CSS file, and it'll pull all of those in to one CSS file. Webpack also inserts our link tags for our CSS into our HTML for us, so we don't have to, insert those. It inserts our JavaScript into our HTML for us. Really nice. It'll also do, it'll like add hashes to the file name so that if we update the files, it fixes our caching issues. And Webpack does a lot for us. And again, Create React App has set up Webpack for us. So we don't even see the Webpack config. It's just Webpack handle or Create React App, set it up, and we kind of trust it to do its job. If you want to dig into Webpack a little bit more, Webpack's really complicated and kind of difficult to set up, but you can dig into it there on its website. I'll show you an example just for fun of where do I have a Webpack example? Let's see. Just to kind of give you an idea of what Webpack is like. I used Webpack for a Vue project, and it looks like, where's my Webpack file? I haven't messed with this in a while. Here it is. Here's like my Webpack base configure. So again, you have all of this, output. This is where it takes each file, it renames it, outputs as name.js. I've got all of these rules and the ways, here's where it loads Babel. Again, this looks complicated, and that's because it is kind of complicated, but it's doing a lot for us behind the scenes. For instance, here it's, taking all of our image files and doing some updates for us. It's packaging together all of our font files. It's not a great example because it's not super clear what it's doing, and that's just kind of the way Webpack is. But once you kind of learn it and figure it out, it does a ton of things for you. But again, Create React App has handled Webpack for us, so we don't really have to see it or think about it, which is nice. But I want you to understand what's going on behind the scenes. Okay, so I want to talk a little bit about some ES6 features. So again, ES6, also known as ES 2016 or ES 2017 or ES 2018 now. It's the new version of JavaScript. They kind of add to it every year. That's why we have 2017 and 2018. ES6 just generally refers to all of the new features. Not supported yet in the browser. So browser JavaScript is still ES 2015, which is not ES5. It's very confusing. ES6 is the next version of JavaScript that browsers don't support yet. One day they will. So eventually we won't have to use Babel, and React will just run natively in the browser, and that will be awesome. But it'll be a few years before that happens because the browsers are still kind of catching up and implementing the new features. I want to kind of cover a few ES6 features that you're going to see a lot when you're dealing with React. So React uses some ES6 features pretty heavily, so I want you to at least be familiar with what those are and kind of understand what they're doing. So the first is some different ways to declare variables. So we have let and const in ES6. There are two new variable declaration types. So these are replacements for var. So you could say var name equals Craig. Here you can say let name equals Craig or const name equals Craig instead of var. So they're just replacements for var or additions to. A few changes or a few differences between let and const and var. So variables created with let and const are block scoped rather than function scoped. All of that means is that they're only available inside of the block of code that they're created in. And a block just means anything inside of curly brackets. So an if statement, for instance, is considered a block. So if you have an if statement and you say let name equals Craig inside that if statement, after that if statement is over and you've got your closing curly bracket, that variable is no longer available to you because it's only scoped inside of that block of code. So again, some benefits to that, it helps reduce your memory load because it'll clean up after itself. It also can kind of help, you can have variables that you just use inside of those function blocks and they're kind of more contained. So you have less concern about overriding them, things like that. Also, sometimes if you forget that that's how it works, which happens to me a lot because I'm still kind of getting used to using these are pretty new. You'll try and use something, you're like, oh, why is it undefined? It's like, oh, it's because I defined it inside that if statement. So it can kind of be a headache at times as well. A difference between, so that's the difference between both of these and just regular var. Regular var, if you define it inside an if statement, it's available to you after the if statement's over. Let and const are both scoped inside of those blocks. The difference between let and const, so let can be overridden later in your code, very similar to var. So let is very similar to var, just with block scoped. Const, however, cannot be overridden later. So it's short for constant. So it just means that this, whatever I set this value to, if you try and overwrite it later in your code, you're going to get an error. So it's a kind of a safety feature. It's meant to be used to let you set, variables that you're not going to change, and it prevents you from accidentally changing them. So it's really just kind of a convenience feature. One small distinction is it doesn't mean that it's immutable, which simply means like if you create an object, so if you say const car equals and then some object, you can still add properties to the object and you can change those properties. You just can't overwrite the variable entirely and say now car equals the string. That won't work. That'll show an error. So if it's an array, you can add to the array, things like that. You just can't completely override the variable. So there's a demo here if you're going back over the slides and you want to kind of see that in action. This symbol will kind of show you that and some further reading as well. So these two links are kind of give you a good overview and some more examples if you want to kind of see some more examples. Again, I'm just going to kind of give you the high level overview of these features. But you'll see let and const quite a bit when dealing with React. Okay, so the next feature that we have to talk about is ES6 modules. So far in our JavaScript, we have no way of importing JavaScript from other files or anything like that. We're just stuck with what we have in that file. We can load additional files in our HTML via additional script tags, and then we have that stuff available to us in scope. But sometimes we want to do kind of a more modular approach and importing certain things. So we have import now in ES6. So similar to Java, you have imports, things like that. We can do that with ES6 now to load external modules from other JavaScript files. This is used really heavily by React. We do this to pull in dependencies, to pull in the React library code. We also do this to pull in components from other files, React components. We have to export the modules in a specific way using the export keyword to export a function or a class or a variable. We can really export anything, but we have to kind of define it in a certain way. A few kind of notes: when we're importing, we can specify what parts of a module we want to import, or we can import all parts of the module. And we can assign them to a specific variable name. And again, import is used by React to load the React library itself, as well to load our components. Oh, and one note, we can also import our CSS files into React components as well. So a nice feature of import, and this is kind of a Webpack feature, where Webpack reads all of those imports and then compiles our CSS for us. But it's really nice. We can break out our CSS now into multiple files and import them in our JavaScript when we use those components. So it helps keep our CSS a lot more modular and only load the CSS that we need based on whatever components we're loading. So here's an example. So over there on the left, we've got our library file, just lib.js. So this is where we're exporting some different variables and different functions. So we can export a constant that's just a square root of something. We can export a function. So we've got a square function that just takes the square root. Or sorry, it doesn't take the square, it returns a square. Whatever value squared. We can also do a diagonal function. So those are just different functions that we're exporting using that export keyword. So now we can import those from our library file. So first we've got our import statement here in our main.js. We can tell it what methods we want to import. So by saying square and diag, we're importing those two functions And we can do that because they're exported over here. And then from lib. And typically inside your from, it's just whatever that file name is. So in our case, lib.js, we would say from lib. If it's in a different folder, we may have to provide the path. We may have to say from, you know, library/lib or something like that, if that's the folder structure that we're using. So then once we've imported it, we can use it. So we can call that square function and pass in a parameter, and we've imported it now, so we have access to that. We'd also have access to that constant we defined, things like that. This example I forgot to change, but another thing you can do is import star. So you can just say import star from lib, and that will import everything that that lib file exports. So if we did import star lib, now we have access to the square root constant. We have access to both of those functions, everything we've exported. There's a more depth you can get into. There's module.exports where we can define, you know, a class. We're not really going to go that in depth. That's how we'll use it with React. So you'll just kind of see how it works. Some further reading here if you want to kind of dig in a little bit more into modules in ES6. Really handy. It really makes JavaScript a lot more of a modern language. It's going to look a lot more like Java or Python or something like that, where you can import, you know, classes and things like that from other files. Any questions so far? Okay, again, we won't really have to implement these ourselves. You know, we're going to follow the, you know, React patterns, but this is what React's doing, you know, when we do that. So I just kind of want you to be familiar when you see this line that says import and say, oh, what's that doing? Now you kind of know what it's doing. Okay, so classes. So ES6 introduced a class syntax for JavaScript. So we've had objects in JavaScript, but now we have a way to do classes in JavaScript, which is really nice. And again, makes JavaScript a lot more modern, makes it look a lot more like Java and other modern programming languages. It's not fully an object-oriented inheritance-based model. It's pretty similar, but just one thing to keep in mind is it doesn't work exactly like Java. So there are a few things that work a little bit differently, mostly with inheritance, the way that it inherits values and properties from its parent classes works a little bit differently because it's really just interacting with JavaScript functions. So we're mostly doing methods and not so much. For instance, you can't do like protected properties in JavaScript classes like you can in Java. So that's just a feature that we don't have. So keep that in mind. It looks a little bit different than other more object-oriented programming languages. We can, however, extend other classes. So we'll use that in React a lot. So we'll create a class that will extend another class. So it gets all the parent class properties and methods. We also have constructor functions, which create, initialize the class object. In JavaScript, we have a super function, which will we call inside of a constructor, and it calls the parent class's constructor. So whenever we call super, that just says, okay, call the parent constructor at this point. So super should always be kind of the first line inside your constructor method because that calls the parent constructor. So it's really important when dealing with React because when we create React components, they're going to be classes that are extending the React class, and we want to make sure we call the React constructor on our, you know, on our component methods or on our component classes, because React does a lot of stuff for us in the constructor. So really important that you call super inside your constructors. And I'll show examples once we get into React a little bit more. ES6 classes use this to reference properties of the class object. So the methods and properties we have, you know, if you have a method called getFirstName, you would call this.getFirstName to call that method. And then we also use, again, we use methods to access and mutate the class object properties. So similar to, you know, Java, we usually aren't accessing properties directly of other classes, but we're calling the methods that will then access or mutate those properties. Again, we won't have to really deal with classes too much other than kind of following that pattern when we're using React. So here's an example. Let me pull this up in CodePen just because I think it'll be a little easier to read. By the way, with CodePen, you can write ES6. You just have to change one setting. Here in your JavaScript tab, you click this little gear, and here on JavaScript, you can say JavaScript preprocessor. You can select Babel, and it'll run Babel then on your JavaScript. So now you can write ES6 here in CodePen. So it's really, really nice. Lets you kind of do some testing and stuff like that. And you don't have to worry about setting it up on your computer and getting Babel to work. You just say, hey, make this run with Babel. So here we've got a class of developer, and it's got a constructor that gets a first name and a last name property. And then we just set the properties of the class to whatever gets passed in the constructor. So this dot first name equals the first name property. This dot last name equals the last name property. Again, probably pretty similar to what you would see with Java or another object-oriented programming language. Then we can have methods. So we've got our constructor method that gets called when we create it, but then this is an additional method that we have available to us on the class. So get full name, and it's just gonna return first name plus a space and then plus last name. So then we can extend that class. So we can say React developer extends developer. First we have our constructor, gets our first name and last name, and we've added a new parameter called experience. That's just a string of, or a number of how many years experience. We need to call the super. So this will call our parent class's constructor. So that sets the first name and the last name. And then we also will set this dot experience equals experience. We're setting the experience property to the experience parameter that's passed in. And we've got some additional methods. So add to experience some number of years. We're going to set this experience plus equals. Get experience, which will return a string saying how many years of experience someone has. So then we can instantiate these objects or instantiate these classes. So we can say John equals new React developer, and we pass in our parameters. And again, that's going to run the React developer constructor, and the first line of that runs the developer constructor. So that's kind of how that super works. So if we console log it, we'll see we've got the full name. Here we can do another React developer. We can call our add to experience method. So again, our Jane here, this object, has all the methods that we can call using our dot. So we can say Jane dot add to experience and pass in some parameter, and that will call that method. And so then if we console log, Jane dot get experience, we'll see the return of that string, how many years of experience they have. Okay, questions on classes? Again, this is just a brief high-level overview. We're not going to really be writing many classes other than our React components that will kind of follow a certain pattern. So, but I just want you to be familiar with what's going on. Our React components will look very similar to these classes, though. Okay, so again, React uses ES6 classes to create components. We'll talk more about components a little bit later. When we create components, we extend the default React component class. So first we have to import it. So we'll do import React and import component from React. That's just the way that we import both the global React class and specifically the component kind of subclass. And then we can create a new class. Class to-do extends component. So by extending the default React component, we're creating a new component called to-do. And it has attached to it all of the methods and properties that come along with a React component. So really nice the way that it works. Components must have a render method. Again, we'll talk a little bit more in depth about these. But this render method on the class provides the JSX to render inside of a return statement. So that's just where we provide the actual HTML that we're going to render for the component. Okay, so JSX. So I mentioned JSX. What is JSX? JSX is an extension to JavaScript. So it's kind of like a library, kind of like a template language. It's kind of an extension. So kind of similar how ES6 is kind of an expansion of JavaScript. JSX is kind of an expansion of JavaScript as well. It's included with React, so it has to be loaded, and Babel, runs and compiles our JSX for us. But it allows us to write HTML directly inside our JavaScript, including embedding variables, creating custom elements for React components, so on and so forth. So, for example, we can say const element, so we're creating a variable named element equals, and then we've just got a Java or an HTML tag right there. It's not wrapped in a string. Notice there's no quotes around that. It's just it's a JavaScript literal. It's our H1 with the value inside. So it lets us actually write our HTML inside of our JavaScript. So JSX is not required to use React, but it's highly recommended. It's similar to ES6. You don't have to use JSX, but I really recommend, learning it. It kind of helps React make a lot more sense. It kind of just makes it a little simpler, even though there's some things that are a little more complicated. So for example, with JSX, there's what our render function looks like, where we've just got a div, we say hello, and then that's where we pass in we pass in a JavaScript variable. This.props.name. So whatever this.props.name equals will be spit in that div right after the word hello. So whatever that variable is gets inserted there. Really nice. Here's what it looks like without JSX. So again, it's not terrible, but we have to call react.createElement, and we pass all these properties. So the thing I've done this a few times where I've used React without JSX, and it's just kind of confusing because there's all of these properties and you kind of have to remember which ones go where. So it's like our element type is first, and then we've got a string that we're passing, and then we're passing in the property. Again, those just kind of go in order so we can add more. It's not a great way of doing things. It's not real clear what's happening. Whereas it's pretty obvious with that JSX what's happening. You say, okay, there's a div, it says hello, and then it has a variable. It's pretty obvious what's happening. That's not obvious at all what's happening. So I really recommend learning JSX. Again, it's just kind of worth digging into, even though it adds some complexity as far as setup. So React uses the JSX to create declarative templates for your UI. So there's kind of two patterns for creating templates. So the first is declarative, which is what React does, which means we describe what our UI should look like, including all of our logic and where our data goes. And then the framework kind of creates that UI for us. So we've declared the UI. We've said, this is what our UI looks like. Here's what it is. Here's where the data goes. And then React says, okay, got it. I'll go build that for you. Imperative style is what we've done already in class. So when we did our to-do app, we did an imperative style of building our UI, which means that it just means that we had to manually create and update the UI step by step. So when we did document.createElement H1, and then say that to a variable and said H1 add class and provide a class and set property ID, set enter HTML and pass in some data. Again, you think of your render function on your to-do app is really long and a lot of step-by-step, really verbose manual going through here's all the things I need to do to create that element. React and with JSX, we don't have to worry about any of that. So we don't have to do any of that step-by-step stuff. It's declarative. We say this is what a to-do looks like, and then React handles creating it for us. So here's an example. Over here on the left, we're creating a button using JSX in a declarative way. So we've just got a button element. It's got a class name, which is just the JSX way of assigning a class. We've got an onClick handler. So this .handleClick will be a method on our class that gets called whenever our button gets clicked. And then we're also passing in some text. So this .state.text will be written inside of the button. As opposed to if you look at the imperative kind of plain JavaScript way of doing it, we have to call create element. If it's clicked, we say classless equals clicked. Whereas there on the left, we're just writing this .state.class into class name. So if that's blank, then class name will be blank. If it's, you know, clicked, it'll be clicked. Whatever the value of that property is what gets written there. We set inner text to button text, which is some variable we've created. Add event listener. So again, we're kind of going step by step, creating the element. Whereas with JSX, we're saying, here's what a button looks like. It's declarative. It says, here's a button. And then React goes through all the steps of actually creating the button for us based on what we've said it is. So again, really nice, really saves us a lot of pain, saves us a lot of writing code. And we can just kind of say what our UI looks like. So another nice feature about JSX that I've kind of alluded to is that we can have JavaScript expressions like variables or even function calls or logic that can be embedded inside our JSX template using curly braces. So over there on the left, we've got a name variable of name equals Craig Hufstedler. And then we create a JSX element where we have a heading, it's H1, hello, and then we have our curly braces. And then we can, inside the curly braces, we can put any variable name. And the value of that variable name will be injected into our HTML there. So super nice. So just whatever the value of name is gets injected into that HTML. Over here on the left is a little more complex example where we've got an object defining our user with a first name and a last name. And then in our JSX, we can call a method or a function like format name, which in this case just concatenates the two. So whatever the result of this function is gets inserted into our HTML. And we've got our curly braces there. So again, inside your JSX, you just use curly braces to say, okay, now I'm going to provide you with a JavaScript variable or a function, or you could even do some logic in there and have an if statement inside your curly brace and say, if this, then this, otherwise this, things like that. So really nice. It lets us to take values and variables in our JavaScript and inject them into our HTML in a really clean way. And it also will, you know, again, one of the nice things that React does for us, this is kind of ironically an anti-pattern, kind of in a more old school approach. It's funny because like when I was learning web development 10 or 15 years ago, especially doing PHP, we did a lot of this kind of thing in PHP and it was really bad. It's really not, we've moved away. PHP, you don't really do that anymore because you don't want to just take variables and write them into your HTML. It's not really a good thing to do because it's not very safe. Those variables could contain, you know, something that breaks your HTML if it's not valid HTML. That could be a problem. It could also contain dangerous, like a script tag or something. Like if first name here was a script tag, you know, that like went and started mining cryptocurrency in your browser or something like that, then saying hello, you know, first name user, it's just going to insert that script tag into your HTML. And now you've loaded some JavaScript in the user's browser. That's not what you want to do. It's okay to do this in React because React actually will make this safe for you. So whenever React sees these curly braces, it takes whatever that value is and it will escape it. It'll make sure there's no HTML, unsafe HTML tags, and it'll escape it all properly. So React is doing a lot of heavy lifting behind the scenes to make sure this is safe to do. So again, it's kind of funny how everything comes around. There's nothing new under the sun. You know, 10 years ago, we were doing this in PHP, and then everyone's like, no, 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 this is terrible. Let's stop. Okay, we'll do proper templating or whatever. Now we're back to writing, we're writing HTML. We're putting JavaScript right on our HTML. But React is doing a lot for us that makes it safe, in theory at least. So I'm sure in 5 years, someone will be like, oh, this is terrible. Let's not do this anymore. And they'll come up with a new way. But yeah, question?
Yeah, just so here, just is format name just a function that was declared? Or like,
yeah.
That just is not.
Yeah, I didn't show that in my example, but that would be somewhere in our, you know, component. Good question. Any other questions? All right. So we can also assign HTML attributes in our JSX. So we can use string values using double quotes or JavaScript expressions using our curly braces. So one note, some attribute names are different in JSX, such as class, because again, JSX is just regular JavaScript. So in your JavaScript, if you say class, that's creating a class. So we can't just use the word class. It's a protected name in JavaScript. So that's been changed to class list. So class list is how you add classes to elements in JSX. Similar to like tab index is now tab and then uppercase index. Same with for. If you're creating a label and you're saying for and then giving it the ID of the input that it's related to, for is a JavaScript loop. So you can't just say for in your JSX, it's HTML for. I'll show you an example of that. This link here will give you the whole list of those changes. The biggest ones are just class list and then HTML4. But if you want to kind of look over those, it's at that link. And one note too is that because React handles all of our updates for us, it's not as necessary to use ID elements or ID attributes. I find that I don't write ID attributes as often when I'm dealing with React because typically you're using IDs in your JavaScript to select an element by ID and change its value or something like that. But React handles all that for us, so we don't have to add IDs quite as much. You may need to for your CSS or something like that. But as far as the actual interactions, we typically don't have to add IDs as much. So here's how that looks like. So here we've got a div, and we say class name equals to do. So again, if we just use quotes, then it's just a string that gets set as that attribute. And then here we've got an image with a source attribute, and we're passing in a URL. So in this case, user.avatar URL, user is just some object that we have. Really in React would probably be this.state.user, but it's just some object, and avatar URL is some URL on that object. But we can pass that in as the image source, passing in that variable name. So you can start to see here kind of where the power of React is in JSX, and that we can kind of create a template. We can create, here's an image and a heading and, a div containing them. And you kind of use these attributes and properties to sort of plug in the data where you need it. So we don't have to rewrite the same HTML over and over. We can have one snippet of JSX that then can be rendered multiple times using different data. So I'll kind of show you how to do that in a little bit. Okay, any questions? So this is how we add attributes to our HTML in JSX. Again, JSX is very, very similar to just our regular HTML. There's just a few changes, and it's inside of our JavaScript. So here's kind of a full JSX example. So this would be a component for our to-do app. So I've got like a heading. This might be a little bit small to see, sorry. I've got like this to-do list up here would be a separate React component that we've imported. I've got a form and an onSubmit property. We'll talk about those a little bit later as well. Again, the rest of it just kind of looks like normal HTML, except I can use those curly braces to pass in different variables. So on these, like that on change on our input, I pass in a method that will get called every time that input gets changed. So pretty nice the way that that works. The slides are already on Canvas, by the way, so if you want to kind of follow along there, you can. Okay, so some further reading. Again, we could spend a whole lecture on JSX, probably a whole week on JSX if we really wanted to. The React documentation has a good kind of intro. This buildwithreact.com is a really good website as well, and they kind of walk through all the different kind of components of React. So they've got a JSX tutorial, and then here's another article as well that is pretty good. So if you're kind of having trouble wrapping your head around JSX, take a look at a couple of these links, see their examples, and hopefully that will help. Okay, so talk about actual React components. We've kind of used that word a lot. So what is a React component? So a React component is just a self-contained UI element that can have data and state information associated with them. So we can kind of think of them as the building blocks of our UI. So the last class I was kind of talking about Facebook here. So if we've got Facebook, we've got like a profile image in our cover photo. We've got like a sidebar. Then we've got like our main content area with different posts. Again, kind of like how when you're building just your page with regular HTML, you're kind of thinking about how to break the page down into different components and different elements. So we might have like a header and a sidebar, and then like a div here that's our main div. We could have those be different React components for each part of that. And then even breaking it down a level further, you know, our sidebar is a React component, but then it's maybe composed of multiple link components. So each of these components may be a link component that pulls in, you know, the various properties. These may be a post component. So we've got like our post section container, and it loads multiple posts. And even a post we could break down further. If it's got like a profile image and a name of who posted it, maybe that's the user info container, or sorry, user info component. And then we've got like the post body component. So we're breaking this down into multiple components that make up the page. So again, they're kind of building blocks. So to show you an example project I'm working on, this is kind of an in progress. Let's see, where's my, there we go. Kind of, we're sort of just building the proof of concept for our React component, but here's like our let's see, platform landing JS. So this is kind of our container element, and here's where we load the different parts of the page. So we've got a header bar component, we've got a platform header component, a content slider component, content container component, additional content component. These are different components that we're pulling in. And then each of these components is made up of additional components as well. I don't know how broken down I have it yet, but like here's my header bar, which is a header. It's got an image, it's got a button component that's actually a separate component that I've created. And this button component has, you know, some different properties and stuff. So again, this is kind of how we use components as building blocks, because then we can start to reuse them. For instance, you know, if this here is a user info component, we're reusing that in multiple places. And we might use that on other places in the page as well, other than just on a post. So once we have things broken down into these smaller building blocks, we can find places where we'll put those building blocks in other areas. For instance, this button, this is just a generic button component that I can use in multiple other components. So that's why we break things down as much as we can. Okay, back to the slides. Again, React components are just ES6 classes that extend the default React component class. So I'll show you an example of that in a little bit. But it's just a class and it extends the React component class. So it gets all of the a bunch of built-in methods and properties that come along with the React class. So again, the most important method for React components and the only required one is render, which returns the JSX for the component. So that's how we provide the actual JSX that that component is creating. We also should always name components with uppercase names, because JSX treats lowercase tags as just plain HTML. So like a div is just plain HTML, whereas capital my div is an actual React component. So a good example of that, you know, like you can even see it here in my header bar. You know, I import button, which is a component, and I use that here with uppercase button. So that's referencing the actual React component of button. And then in my actual button component, I use lowercase button. So now I'm creating an HTML button, not an actual React component button. So that's kind of the difference. That's why you want to make sure your own components are using uppercase. Yeah, do you have a question?
Yeah. So it looks like there are two header bar classes, like this one here that we're looking at, button.js, and one actual header bar.js.
Oh yeah, you're right. This one should be button. Good call. Button. Thanks. Export button. That was a good call. Again, this is an in-progress app, but thanks for catching that. Probably would have run into that bug at some point. So yeah, so make sure your components are always uppercase, capitalized. Okay, so components are designed to accept properties that we call props that are assigned when the component is created, and then they're used throughout the component. So this is how we start to add variables to a component and start to track the properties of a component. So we pass them in JSX using attributes. So here, for instance, we've got a to-do component that we're initializing or instantiating, and we can pass a text prop using an attribute. So again, you know, with HTML, we have certain attributes that we use. We have ID and class. With JSX now, we can use any attribute we want to indicate a certain property to create those props. So text is just, you know, finish learning React. Or we can pass a variable in a prop. So we can say text equals to-do text. So that to-do text is some variable that has that, that property. Or we might pass something from state, something like that. We then access props inside the component using this.props and then some prop name. So we can say, you know, inside of our to-do component, we might say, you know, a paragraph, and this.props.text is what we, how we access that property. So super cool feature of React, which is why I bolded this, because it's very cool. When props are updated, the component is automatically re-rendered. So if this.props.text ever changes, if you just update in your code somewhere, this.props.text now equals something else, your component will automatically be re-rendered. So that render function that provides the JSX will get called again every time this.props.text changes, which is really, really nice. That's very hard to do in just plain JavaScript. You can do it, but it's very hard. So React has done a lot of that hard work for us, and anytime that those properties change, our component will be re-rendered. That's really the main selling point of React. So again, I'll show you an example here of using props. This is my been working on my own React to-do. So here in my app.js, you can ignore the state stuff for now. Just you know that I've got an array of to-dos here. So I haven't done my Ajax stuff yet. I've just got a hard-coded array of to-dos that have an ID property and a text property. So then here, let's ignore this as well for right now, but I can instantiate my to-do properties, and I can pass the props. So in my case, I'll do to-do ID equals 1, 2, 3, 4, and text equals some, you know, to-do text. Oops. And then that creates a new to-do component with those properties. And then inside my to-do component, I access those properties here. So I have got my article. This ID really should just be this.props.id. And this is fine. This should be this.props.text. So whatever gets passed, I think I've got something. Oh yeah, thank you. There we go. Cool. So again, this is how I access those properties that are created when I instantiate my component. So again, to recap, when I create the component by saying, you know, my JSX to-do, and this, I've imported this, I've done import to-do from to-do. So that imports my to-do component class that I can then create instances of. So I create it here with to-do, and I pass in an ID, and I pass in my text. And then inside my to-do component, I can access those properties by saying, you know, this.props.id and this.props.text. So really nice. Just to give you a little spoiler alert, here's where I would loop through my array, and for each item in my array up here, so this.state to-dos is an array of to-do items. For each one, I can create a to-do component, and I can pass to-do.id and to-do.text into it. So that's kind of where we're going for the assignment, is you'll do something like this. We'll probably won't talk about you know, the pattern for this until after break, but spoiler alert, where we're headed. Okay, component props. Any questions about props? Again, it's one of those things that kind of starts to make sense once you use it a little bit. So real quick note, again, we don't really have to worry about this because Create React app is kind of doing this stuff for us. But React renders to the page by calling react-dom.render, which gets two arguments. First, it gets the component that we're rendering. So whatever component class we're rendering, usually like your container component or your app component or something like that. And then as a second property, it gets the root element on your HTML page that it renders the JSX into. So we have to have an actual HTML file when we're using React, and we have to have one element on our page. Usually it's a div or a main with an ID of root, which is just kind of a common pattern. It can be whatever you want. But then we tell React, okay, render all of our components and put it inside this element in the HTML. So we kind of have to have a root element in the HTML that React then puts everything into. And you do that by calling document.getElementById and then root in our case. So, you know, for example, in my to-do, and yours is already set up this way. So again, you don't really have to worry about it. Create React app uses index.js for this. So we import the app container, and then we call react-dom-render. We pass the app component, and we write it to document.getElementById root. And you can look at your HTML. If you go into public index.html, you can see this is the base HTML that React is using. So it's got your doc type, because React doesn't help you with that. It's got your head stuff. React doesn't deal at all with the stuff in your head. There's a few plugins that will help with that. And you'll also notice there are no JavaScript file, there's no script tags or link tags in here, and that's because Webpack injects them automatically. Webpack, you know, looks at compiles all of our JavaScript and CSS, and then it creates the script tags and injects them like right before the closing body tag, so on and so forth. But then we've got this div ID root. That's the only actual HTML we have on our page, is this div ID root, and that's where React injects the page. So if we actually run this, we'll see it is running. If we pull it up and inspect, we will see that, you know, here we've got our body and we've got our div ID of root. And inside that is all of the elements created by React. So again, we have to start with that initial div. And again, Create React app has handled all that for us. It's created those files, it's hooked everything up, so we don't have to worry about it, which is nice. But we need to kind of understand what it's doing behind the scenes. Okay. Again, kind of along the same vein, composing our components. Really the most common pattern for building UIs with React is to use exports to export your component classes and import them into an app or a container component of some sort, which builds the UI using all of your various components and then renders it. So again, this kind of helps keep a separation of concerns. You can have different UI elements in different files, and it kind of keeps things more streamlined and cleaner. It also allows you to reuse those components in different contexts. So again, the more granular you get with your components, the smaller your building blocks, the more often you can reuse them in other places. Again, Create React App abstracts this even further by having your index.js file that loads your app container. So again, we've got our app.js, which kind of composes our page. We talk about composing components, which I don't like the way that sounds, but we talk about how we compose, which is how we pull in different components that we need. So in this case, I've got my new to-do, which is my form, and I've got my to-do component, which is each to-do. And then in my app.js, I add my new to-do form, and then for each of my to-dos, I add the to-do. I add that. I don't know why this closing tag is there. I add each to-do. Same with my work project. It's a little bit more complex than that for work. I have things broken out into container components and component components. Containers here are the actual pages. So like platform landing is a page. And I import all of my components using import. So I import my header bar, I import my platform header, and those are all just different components that I have in separate files. And then I compose those components here in my JSX by instantiating each one. So again, that's just a common pattern. You can do it different ways. Again, React is kind of just a tool, but this is typically how most people structure their apps, is they have one kind of container. In my case, I even still have an app.js. This is using React Router, but typically you have one kind of container app.js file that will then pull in all of your separate components. So again, Create React App kind of handles that for us. You don't really have to worry too much about the structure because I've already kind of set that up for you with your to-do component and your new to-do component. Okay, so again, here's just an example. Over there on the left, we've got our to-do.js. Real quick. We import React. We extend the React component for a new to-do component. Then in our app.js, we can import our to-do component, and then we can, create each of those to-do components as we go. So that's typically how we will do things. Okay, so some further reading on components. Again, if you want to kind of dig into it, if you need some more examples, all of these links are pretty good. So there's the React documentation is pretty good. There's their page on components and props to kind of see some more examples of props. This page has an exercise. So again, buildwithreact.com is really good. In each of their pages, they have like an embedded code editor that lets you kind of change things and kind of see how it works. And here's a good page as well. reactenlightenment.com is also a really good page, for digging into React. Okay, so component state. So when we think of props, props are controlled externally. So if we go back to our to-do here, our to-do has this.props.id and this.props.text. The to-do component doesn't actually have any control over those props. It just accepts the props. They get passed to it when it gets created, and it has to render it. It can change them, but it doesn't have a lot of control over it. They're created here by the container element. So whatever's creating the to-dos is what has control over those properties. So state is a way, it's internally controlled by the component. It can be used to track changes to data within the component. So props are kind of what we use when we need to pass data from one component to another. And state is what we use internally within the component to kind of track the data and track the changes inside of the component. So we use state for things like form inputs, user status, if users logged in or we're viewing a certain user, timers, or other data that's expected to change. So anything that we need to track changes of, we save in state. State is encapsulated into a specific component. So it's only in the component that we're working with. So if we need to pass information from the state of a component to another component, we can pass that as a prop. So again, props are, sending the data from one component to the other. So we can say, pass state information through a prop to another component. But generally, state is internal to a specific component. Again, I've bolded this because it's awesome. Whenever our state changes, the component automatically gets re-rendered. So that's really awesome. So for instance, when we do our to-do app, we're going to have our AJAX call to fetch all of our to-dos. And then if we write those to-dos to our state, that will automatically trigger a re-render of our React component. So we don't have to recall our render function. Just any time in our component when we update the state, the component will get re-rendered, and that state will then be updated in our actual HTML. So super, super nice. And it's hard to understate how great that is. That's why everyone loves React, because it does that for you, which is mind-blowing. So we store state in this.state, and then different properties that we save. So like this.state.first name or this.state.last name. So here's an example of how we would set state as this.state equals, and then some object with some properties and values. So we set state initially in a constructor method of our component. So far, when we've looked at component classes, we only have one method. We have the render method that provides our JSX. Another method that we can use is the constructor method. And it gets called whenever the class is instantiated. So right once a new instance of a component is created, our container or our constructor method gets called. The very first line inside your constructor should be super. And we can pass in props if there are any. So for this, in this example, we've got our constructor with props, so it accepts some props, and we call super props. So again, that's going to call the parent class its constructor, and it's going to pass all the properties to it. So that's really important for React because that's what initializes a lot of the React features. If you don't call super at the beginning of your constructor, things like the automatic re-rendering when state changes won't work properly because you haven't called the React component constructor, the parent one. So really important. So the first step in our constructor is to call super. The second step is to set our state. So we always set the initial state inside the constructor method. So we can just do this.state. In our case, we're creating a clock. So it's class clock. So this.state equals, and it's an object where date equals new date. So the date property of our state is set to just a new date object. So this.state.date will be the current date. Kind of a confusing way to say it. So that's, again, constructor here is just a method, and then we've got our render method that provides the actual JSX. So this constructor runs before the render method runs. Not because of the order, but just because that's the way the React lifecycle works. It'll always call constructor first, and then it will call render. So then we can actually write our state in our JSX. So again, this might be a little small to see, but we've got our div and an H2 that says it is, and then this.state.date, which references our date up here, and then .toLocale time string, which just converts the date object into a string. So our H2 now will say it is such and such time, or such and such date on such and such time. So that's kind of how we would track state. So again, this clock component here, it's not expecting a prop that's, where the container, our app.js is passing some time. We can just instantiate a clock component and it will just always have the current time because that's all managed in its state. So it's an internal data for the component rather than an external prop that gets passed when it's created. Does that kind of make sense? Again, as we go through the to-do, I'll kind of explain when you want to use props and when you want to use state. But again, when we think of props, we're thinking of passing data from one component to the other. When we think of state, we're thinking about internally managing data within the component. So data that may change, because we could update this. We could change the date and our clock would change. So that's all going to be managed via state. Here's an example. So outside of the constructor, very important. In the constructor, we say this.state equals, but outside of the constructor, we update component state using this.setState. Very, very important. It's what makes sure the component gets re-rendered properly whenever the state updates. So outside of the constructor, we never do this.state equals. If you do, it won't properly trigger the re-render and all the other life cycle of the component. Instead, here's a method called update date, and we say this.setState, and we pass in a new state object that gets updated. So we've got our date, so we're saying we're updating the date, and we're passing in a new date. So I didn't really show this, but we could have like a button here that has an on click that calls update state. So whenever that button gets clicked, it's updating the date. Or we could do every second, we could update the date, and every second it would show the time change for that second. So again, really, really important. In our constructor, we say this.state equals, and everywhere else outside of the constructor, we do this.setState, and we pass in a new object with updated values. Does that make sense? Again, it's just kind of the pattern that React uses, but you have to do it that way or else it won't work properly.